So yeah, so let's just continue and we'll up the speed a bit for these 10 questions because तफरीयों में काफी time लग गया था पहले 10 questions में. Uh,
Let's
so,
get started with this one.
yeah. So ammonia is manufactured from this Haber process. What expression for Kc? Remember with Kc, it's products की concentration divided by reactant की, and the moles हैं, that should be your क्या कहते हैं, your power. So either because it's coefficient and coefficient power नहीं बनाया 2 को, so that's wrong. Either it's product over reactant दोनों सही है. Either the only issue is the plus sign, तो like plus sign तो नहीं होगा, it's multiplied. So like 11 is D. Sahi. Let's go with 12. The electrical conductivities of two compounds Y and Z are shown in the table. So Y conducts in liquid state and in aqueous. Z does not conduct in liquid, but it does conduct in aqueous. And liquid में conductivity comes about by moving of ions. सही है. So it's you want something that's ionic in this particular case. That would happen. And obviously ionic stuff does ionize and just conduct in aqueous. For Z, you want something covalent, ideally something that is an acid, ताकि aqueous में conduct कर ले, liquid में नहीं करेगा because ions नहीं होंगे. So Y and Z, so इसको काट दो, इसमें ionic, it's an amphoteric oxide, so ionic nature भी होता है, covalent भी होता है. इसमें तो covalent ही है, it's an acidic oxide. This is purely ionic. And वही वाला जुगाड़ के it's appearing 2 times, तो यही होएगा यार. And actually works.
Don't teach these guys this thing, no.
It actually works. नहीं कुछ नहीं आता तो this is 2 times.
If you're like literally so dumb कि तुम्हें कुछ नहीं आता, then this works. पर ना नहीं.
Bro, like it's helped me in many a paper. But okay, so Z, we want something. I wouldn't take Al2O3 amphoteric. I would take this acidic chloride. Because again, chlorides की acidity increases left to right in period 3. Because the idea is if it's acidic, it can hydrolyze in in an aqueous medium and conduct. However, because it's purely covalent nature, so like it won't conduct in liquid because उसके ions नहीं होंगे. So we'd go with C. So 12C. 13. Which reagent, when mixed with ammonium sulfate and then heated, liberates ammonia? And इसमें क्या idea था? Ammonium sulfate.
The idea was that because it's an ammonium salt, and the test for ammonium salts is the addition of alkalis and then heating them, it liberates ammonia. And lime water is the common word used for calcium hydroxide. So
which is which is an alkali, which is basic. So basically, yeah, you're good. Why does barium react more rapidly with cold water than magnesium does? So reacting more rapidly, the reason, if we it'll be more clear if you look at the periodic table. So idea is if you go down, if you go down group 2, magnesium idhar hai, barium idhar hai. So as you go down, shells increase. So your valence shell में 2 electrons होंगे, वो और भी दूर हो जाते हैं from the nucleus, and shielding also increases. So barium experience के 2 electrons at the valence orbit में, they experience much less, substantially less or substantially weak क्या कहते हैं, nuclear force of attraction in comparison to magnesium. Ergo, it is easier for barium to lose those 2 electrons. If it's easier for barium to lose those 2 electrons, barium will be more reactive, because for metals, reactivity is like losing those 2 electrons to form 2 positive ion, right? So जितना वो आराम से lose कर सकता है, उतना ही वो ज़्यादा reactive होगा. So if we read these statements, barium atoms are larger, which is true, and form ions more easily than magnesium atoms, and this is a pretty good explanation. Barium floats on the surface of the water, but magnesium floats in things तो कोई ताल्लुक नहीं है. Barium hydroxide is less soluble than magnesium hydroxide से भी ताल्लुक नहीं है. They're both ionic hydroxides. The sum of the first and second ionization energies of barium is more than that for magnesium. I mean, if they had said less here, it might have made sense. Because ionization energy is basically, removing the 2 valence electrons, right? So ionization energy decreases down the group because of what we talked about, shells and nuclear force of attraction. It decreases down the group. So barium की ionization energy first and second को add करो, it should be less than magnesium. If that was the case, then you could link it to how it's easier to lose those two electrons, which is why ionization energy कम है, and hence
Yeah, because
it's
in
more
the case
reactive.
of metals, जितनी कम होगी ionization energy वो उतना ज़्यादा reactive होता है, and it's the opposite for non-metals. कि non-metals में जितनी ज़्यादा first ionization energy होगी वो उतना बेहतर non-metal है, that is that it's easier for it to accept an electron.
Yeah.
So
14a we have. Let's go to 15. The magnitude of the property X of 5 elements from the third period of the periodic table is shown. They have consecutive atomic numbers. The letters do not represent the symbols. Obviously, which row correctly identifies property X in element in and element R? यार मैं बता रहा हूँ property X तो यही होगा. इसमें दो दफा आ चुके हैं ना. So like, but like seriously, if you look at it, so you're moving left to right because atomic. How do you know you're moving left to right? Because atomic number increase हो रहा है, and एक किसी का बहुत high है. So I would guess this is your silicon because it, and ये melting point की बात कर रहे हैं, because silicon, you know, giant molecular structure में जो exist कर रहा है, because of that it has an extremely high melting point. Because and if you take this to be silicon, then if you look at it, phosphorus, sulfur, so फिर silicon के आगे वाला would be phosphorus, silicon के पीछे वाला would be aluminum, magnesium, and Na, which makes sense वैसे if you think about it, for because melting point आपका बढ़ा Na is to Mg because the charge increased. So although it's a metallic lattice, but obviously positive charge in एक electron को compare करो उसकी force of attraction and two positive charge and two electrons की force of attraction would be more. इधर भी थोड़ा सा बढ़ गया आपका सही, and it really goes high for the giant atomic structure and really comes down for your non-metal, because non-metal ka melting point it should be below even the metal, the lowest metal, which is what's happening. So it should be melting point. It can't be electronegativity because electronegativity increases left to right. So this shows कि कम हो रहा है. It can't be electrical conductivity because silicon जो भी इधर है इतना drastic gap on electrical conductivity नहीं नजर आ रहा. Like, you know, it doesn't make sense कि एक में increase हो but थोड़ा सा normal है फिर, you know, इतना drastic gap, it doesn't really show that. आपके the metals would be, the first three would conduct, उसके बाद the electrical conductivity would go really down because you get to the non-metal, silicon, phosphorus, and so on. So yeah, so it has to be melting point, or you could just believe in my जुगाड़ के दो same है तो वही होगा. But whatever. And since we've identified this, silicon को हमने identify कर लिया, उससे हमने बाकी सब कुछ identify कर लिया. This would be aluminum. This would be C. So 15C. सही है. Then you have 16. Some uses of chlorine and bromine are given. What is a use of bromine? And this is there's not much to explain in this. It's used to make flame retardants and fire extinguishers. It's just like more knowledge based. But let's go to 17. In an experiment, 0.6 mole of Cl2 is reacted with excess of hot aqueous sodium hydroxide. One of the products is NaClO3. Which mass of NaClO3 is formed? So basically, if you know the equation for this, then you're good. Idea इसमें यही है कि it's a disproportionation reaction. So chlorine would be either जैसे +5 होती है तो it's oxidized, कहीं NaCl भी बनेगा तो -1, so it's reduced at the same time. So let's you take Cl2 and you take NaOH. And the way I like to remember this, because मुझे ये equation कभी भी याद नहीं होती. एक तो like पहले you just write all the reactants and the products. So एक आपको ये बनेगा. सही है, because this is given. The other would be NaCl, because it's a very common disproportionation reaction. So you should know that NaCl banega so that -1 ban sake, ताकि, you know, it's oxidizing and reducing at the same time. And where will the H go? It will form H2O. So yeah, so you have your and it's really it's much simpler if you just memorize the equation. But at least products and reactants, so याद मतलब logically भी आ जाएंगे. And what I like to do, I just remember कि ये 6 है. Because the balancing of this equation is a pain otherwise. So I just remember कि हाँ 6 NaOH है. From there on, balancing is very easy. So I just remember the 6 है. 6 ये है तो 6 hydrogen भी होगा. So which means this should be 3. Say it, अगर 6 करने के लिए. ये 3 है तो this is 3. And if you look to the left, so there are 6 oxygen atoms to the left. So to the right, there should also be 6 oxygen atoms. And either there are 3, which means there should be only be 1. Like either 3 or either 3 or. Like, overall 6 oxygen atoms to that. Which means either 1 sodium hai, हालांकि overall 6 sodium hai. So which means the rest should be done by this. 5 plus 1 sodium, 6 sodium. Which means this is 5 chlorine and 1 chlorine here. So 6 atoms of chlorine or 3 moles of Cl2, because 3 into 2 is 6. And you have your equation, well balanced just by remembering 6. So if you look at it, chlorine का जो अगर आप ratio निकालो with the product that is NaClO3, that is 3:1. So if you look at 0.6, it should be 0.2. Basically, cross multiply कर लो या just look at it's being divided by 3, so इधर भी divide by 3 कर लो. So yeah, so you know कि this इतने moles of this product are being formed, and you simply use the equation N is equals to mass over mR. Whereas you can just do it by ratio method as well. I used to do the ratio method a lot. Then I realized it's just easier to remember the 1 or 2 equations. ये एक होती है आपकी, दूसरी is equal to N is equals to CV, and the last is N is equals to volume divided by 24,000. 1000 because volume अगर centimeter cube में है तो इसलिए 1000. Ratio method is also completely fine, but I just memorize the equations because I'm like, yeah, it's just, I mean,
and conceptually it also makes sense, no? And
like ratio को अगर आप इधर उधर करो तो you'd get the equation. You can derive the equations from the ratios. Okay, so if we want to find out the mass, so we just take mR and multiply here. We have the number of moles, that's this 0.2. mR क्या होगा? Sodium is 23, calcium is 35.5. This is 16 into 3. So mR is RI 106.5 into 0.2 कर दूंगा. So that's 21.3. So 17A. Sahi. 18. Z is an anhydrous compound of group 2 element. When it is heated, Z undergoes thermal decomposition to produce 2 different gases. That's important. इधर देख के आपको पता चल जाए कि it's a nitrate. Z has relatively low thermal stability compared to other group 2 compounds containing the same anion as Z. So what is the compound Z? It can't be carbonate. Why? Because if you have carbonate, if you have, let's say, BaCO3, this basically forms Ba plus CO2. So the idea is that with this you don't get the 2 gas वाली चीज जो थी ना, because CO2 ही gas है, दूसरा आपका solid है. If it's a nitrate on the other hand, so you do get that because it still makes, आपका क्या BaO plus 2NO2 plus half O2, excuse the handwriting. सही है? So because these two are gaseous, so you know it's a nitrate, and we want relatively low thermal stability. Now thermal stability increases down group 2, so relatively low should be magnesium. But if you are interested in finding out why thermal stability increases down group 2, is because as the atoms increase, there was a concept known as small size greater charge, and the smaller the size, greater the charge, more the polarizing power. So hence, if you go down group 2, if you imagine larger the size, smaller the charge, smaller the polarizing power, so the lattice is more stable. It's more structured. So down the group, polarizing power कम है, so lattice will be more stable. So hence thermal stability would be a lot. It would be pretty stable or high stability होगी. So it won't be barium because that's down the group. It would be magnesium because that's on top, like on the higher end of group 2. So that's 18D. 19 करते हैं. Methylamine, which is this, has very similar chemical properties to ammonia. And they're probably just talking about the fact that they're both basic, like because of the lone pair. Because ergo they can both accept H positive ion. So this reacts with hydrogen chloride to form white crystalline salt. A sample is then heated over aqueous sodium hydroxide, which is an alkali. What are the products? So if you look at here, this is basic. But I think this is what's happening. It goes to what we can call a conjugate acid, because now this can lose H positive. So H positive gain kya hai, it can lose it. If it's losing it, it's acting as an acid. So this can be called a conjugate acid. Now we're saying a conjugate acid is reacting with an alkali. So neutralization should happen basically, right? So you can cut out B right there because you don't see water. You know, neutralization mein obviously aapko water to hona chahiye. So if you draw this, हमने CH3 NH2 I believe आपको हो जाएगा. I mean Cl को मैं अलग ही रख रहा हूँ because ionically ही joined था. Because the H positive which जो पहले इधर इसमें आया जो था वो चला जाएगा, and that would form water. You know, like ये हो जाएगा इसके साथ. And जो आपका Cl negative बचा है, I think वो सोडियम के साथ NaCl बना देगा. Just to better understand this particular equation, if I just use blue for a second. So basically you had CH3 NH3 positive Cl negative plus NaOH. And what I'm saying, what happened was that आपका CH3 NH2 रह गया, H positive चला गया into the OH negative sign to form H2O, that is water. H positive and OH ही form करता है water neutralization. बचा आपका Na negative and Na positive and Cl negative, so that would be NaCl. So you're looking for whatever this was, you're looking for water and you're looking for NaCl. So sodium chloride, water, methylamine, that is D. And I guess that's we'll do the question 20 in the next one then. That's what the mess kar diya humne. Let's quickly check our answers though. So 10 to 19 check karne. So B, 11D, 12C, 13C, 14A, 15C, 16C, 17A, 18 and 19D, and that's it. And हमारे essentially we're good. We didn't mess up. So all of them are correct. So yeah, and we'll just continue from the next one.
Yeah.